Hi, everyone.
Hi.
My name's Abby. I'm a student at North Carolina Central University. I'm a junior, so I'll be graduating next year. And last year I did a project on the geologic history of Kankakee. So as we all know, the rock cycle, I just wanted to give you guys a little refresher. So we have sedimentary stone, comes from sediment like sand, and it becomes compacted and turns into rocks. Then we have igneous rocks that form from magma and lava, and then metamorphic rocks that form from heat and pressure. So the difference between a rock and a mineral is that a rock is generally made up of two or more minerals mixed up through the geological process, and a mineral is naturally occurring substance. It has distinct chemicals and physical properties, compositions, and atomic structure. So quartz crystals are a mineral, feldspars and micas are minerals, and granite and limestone and sandstone, they are rocks. So rocks you will find in our area, of course you'll find limestone, lots and lots of limestone. You'll also find pyrite, shale, clay, chert, jaspers, mudstones, coal, coral fossils, and Pennsylvanian age fossils, like trilobites, ammonoids, and worm burrows. So rocks you can find at the Kankakee State Park, limestone, which is made out of calcium carbonate, and dolomite, which is made out of calcium magnesium carbonate. It has a little impurity of magnesium, which makes it 10 times stronger. The best way to tell them apart is by color and granular appearance, because dolomite has a sugar-like structure. And pyrite, you can find those on limestone. I have some here actually today that I found at the state park. It's made out of impurities of iron and sulfur when it dissolutes out of the limestone. So some vocabulary I'll be talking about today. We have glacification and moraines. Glacification is the process of the earth being covered by glaciers or masses of ice. And then moraines are massive rock sediment carried down and deposited by glaciers, typically on its ridges or its ends of its extremities. So the best way to describe what a moraine is, imagine a giant rock, say for instance this one, as it gets pushed across the land, or for instance the table, you can see that it bunches up. And this is what causes a moraine. So all of this pressure and pushing causes the dirt to pile up, and it causes this ridge, and on the other side is the glacier, and this is where the glacial melt lakes form because they are being held back by the moraines. So Kankakee County is located 50 miles south of Chicago. We have 16 towns in our county. Kankakee is the largest town with a population of 109,924. I believe it's more than that now, but when I was doing my research, that's what the number was. Kankakee County has a very, very flat landscape, which I'm pretty sure you're all used to. We're flat, we have farmland, prairies, wetlands, and of course the Kankakee River. So the Precambrian landscape of Kankakee, it was 1 to 1.5 billion years ago. The surface consisted of granite and rhyolitic rock. It's not exposed anywhere in Illinois. The landscape consisted of mountainous hills. So imagine our area being as flat as it is, looking like Tennessee with the hills. Plate movement ceased and plates began to pull apart, creating a rift. And that's what brings us to the Paleozoic landscape of Kankakee. So this rift, the Appalachian Mountains and the Rocky Mountains, as they were forming, the middle of our land where we are today started to pull apart. And this created the elevation to lower, and this allowed seas to go in and out, receding back and forth for millions of years. So the seas receded and advanced for 280 million years. The region continued to sink until at least 15,000 feet of sedimentary strata were deposited. So sedimentary strata is basically sand and mud. The landscape was vast with dark humid swamps, which later became coal deposits, as coal is an organic rock and it forms from decomposed animals, plants, and soil. So the Mesozoic landscape of Kankakee, there was actually dinosaurs here at one point. But there's no dinosaur fossils to have ever been found because of the extreme wind and weathering. It It was warm, dry, with hills and valleys. So the wind was very strong. Imagine Hurricane Katrina times 100. It would literally take the ground and just blow the bones away. So that's why there's no dinosaur fossils here in Illinois. First ever flowers bloomed as well, including magnolias. Then we have the Cenozoic landscape of Kankakee, which began after the extinction of the dinosaurs. It was the start of the very last ice age, which we are still currently in. Humans began to inhabit the area, also known as the Paleo-Indians, and mammals and birds evolved. The glaciers advanced, retreated, and periodically. So as you can see here, let me go over here. So we have some lobes. So this is where the glaciers first started. They were covering the entire state of Illinois, and as we got towards the last part of the ice age, the glaciers covered our area here up in the northeast. And as you can see here, we have the lobes. So there was the Lake Michigan lobe, the Signal lobe, and the Lake Erie lobe. So these are glaciers, and glaciers need an outlet for their glacial meltwater. So these lobes would glacial meltwater out into the Lake Chicago, which is now one of the Great Lakes, and it would go down into the Kankakee River and was held back by one of the moraines over here. So the Kankakee Torrent, this is what shaped our land today. The Kankakee Torrent was a catastrophic flood that occurred 15,500 years ago during the Pleistocene epoch of the Cenozoic era. 3 glacial lobes drained through the Kankakee Valley due to lack of outlets, and water broke through the Valsboro moraine, washing out the Kankakee Basin. So this was waves like a tsunami, but 10 times more powerful than a regular tsunami. The waves were at least 180 feet tall. The water broke pieces of bedrock off, forming giant boulders, and these boulders were like the sizes of cars. And you can find these boulders here in the Kankakee Valley today. I have a video from the Peoria Riverfront Museum that explains it a little better than I can, so you can watch that if it wants to work.
In a time when immense glaciers took hundreds of thousands of years to shape the Earth's surface, a cataclysmic flood, the Kankakee Torrent, dramatically reshaped the landscape, almost overnight. Vast glaciers advanced and retreated across most of present-day Illinois during the Pleistocene Ice Age. At the end of these glacial cycles, the receding glaciers created enormous amounts of meltwater, forming new river channels and filling old ones with sand and gravel. Meltwater also became trapped behind deposits of rock debris that built up at the edges of the moving glaciers. These deposits, known as moraines, acted like dams, holding back the water and forming glacial lakes. Lake Michigan began as a glacial lake and was 60 feet higher than it is today. Geologists speculate that around 14,000 to 18,000 years ago, part of an immense glacier broke off into a lake in what is now northern Indiana and Illinois, causing unimaginable amounts of meltwater to surge out and over the glacial lake shores. The waters broke through the moraines in a torrential flood to form what we now know as the Illinois River Valley. This event is known as the Kankakee Torrent. The front of this raging flood was a wall of water that reached up to 180 feet high. Behind it, hundreds of thousands of cubic feet of water rushed forward every few seconds, many times more powerful than a tsunami. The flood's energy was so great that it broke off chunks of bedrock and carried huge boulders, debris, and sediment along with it for over 300 miles, far into southern Illinois and southeast Missouri. To Paleo-Indians living in the area at this time, the sight of a towering wall of water and the sound of its deafening roar would have been terrifying. It must have seemed like the end of the world as the water rapidly swallowed the land. Even to us today, such a torrent would look unreal, like something out of a disaster movie. A wall of water so massive and loud and moving so fast, we would think it could only be created by Hollywood special effects. The raging floodwaters of the Kankakee Torrent flowed westward until they reached the ancient Mississippi River channel. At this point, near what is now Hennepin, Illinois, the floodwaters turned southward, forming the lower Illinois River Valley. Evidence of the torrent can still be found today, telling the story in the topographical characteristics of the area. Starved Rock State Park, located along the Illinois River, has many examples of these geological features. As the surging floodwaters passed through the Starved Rock area, it scoured the riverbed, cutting deeply through the sandstone and other sedimentary rocks as it sculpted towering bluffs and canyons. Scour marks can be found on the canyon walls at 180 feet above the current river level, and elongated ridges of deposited sand and gravel, known as rubble bars, can be seen more than 200 feet above today's river level. South of Peoria, the floodwaters slowed down, depositing large amounts of sand and gravel along the Illinois River floodplain. Had the glaciers continued their slow and steady advance and retreat over many thousands of years, the Illinois River Valley, which has influenced and sustained the people of this area for generations, might never have been formed. But the Kankakee Torrent's tremendous force and speed shaped this entire river valley with its deep canyon walls and fertile floodplain in just a few weeks' time.
Yes, that explained it a little better than I could. So thanks to the Kankakee Torrent, we have the Illinois Valley River Basin, which is the Illinois River, and that does sustain us a lot with fresh drinking water and power. So if it wasn't for our Kankakee Torrent, we wouldn't really have fresh drinking water here in Illinois. That's not what I wanted to do. Hold on one second, it's being weird. Okay, so I have an elevation map here of Illinois. And as you could see where the moraines were at one point. These little white ridges here, these were moraines. This is the Kankakee River. So, well actually this is Kankakee River, this is Illinois River, but the Valspar moraine was up here and the water flooded out. And you can see where the flood pattern is as it went all the way to the base of these moraines back here, and it broke through all of these moraines. So here I have the geologic time scale. So in the very bottom, we have where our land was covered in hills, kind of like Tennessee. During the Paleozoic era, we had seas. The Mesozoic era, we had wind. And the Cenozoic era, we had glaciers. So that puts it in a little bit better perspective. The Kankakee Basin formed once the torrent ceased. Within this red line on my map here, you can see where this was completely covered in water. Oh, it's a touch screen. Okay, so this was completely covered in water. It was covered in rich swamps. So imagine Louisiana or Georgia with their swamps. That was what it looked like here at one point. It had fine-grained sand sediment due to the outwash of the Kankakee Torrent and meandered along 250-mile course across northwestern Indiana and northeastern Illinois. So I'm not sure if you guys are familiar with early Kankakee history, but the Grand Kankakee Marsh was inhabited by the Potawatomi Native tribe in the early 18th century. And when the settlers came to Kankakee in 1934 to establish a township, they had efforts to drain the marsh during the Civil War for better transport of goods. But it wasn't really going nowhere because we had a lot of limestone blocking the river. So they made a steam-powered canal, which made little effect, but then Indiana blasted through the natural limestone barrier of the river, and the river was allowed to flow more freely in draining the marsh, which exposed much more limestone bedrock. Due to its durability, limestone was the building material of choice during the early 1800s. The first limestone quarry in Kankakee opened up in late 1852. The limestone mined from this quarry was used for the building of the Illinois Central Railroad. Demand for this material skyrocketed, and almost a dozen more quarries opened up within a few years. In 1867, Kankakee Gazette article described local quarrying operations, noting that stone of superior quality and infinite in quantity is the best in the state and could be found but a few feet below the surface. And that's still true today. You go digging in your backyard, you'll find limestone with trilobites in it. Limestone from these quarries were used to make buildings around Kankakee that are still standing today, including the First Baptist Church, which is found behind St. Mary's Hospital. So during my research, I found a field study guide for the Kankakee River State Park that was made by the Department of Natural Resources and Illinois State Geological Survey in 1998. So that was a little while ago. But I followed one of the stops. They had 7 stops in total. Then my favorite stop was the Rock Creek Gorge, which many of you have probably been to. It's found at the Kankakee State Park. It's 1 mile start to finish, and it's a roughly 3-hour hike. So the first stop is Horse Thief Cave. So the only caves in Silurian age rock in Illinois can be found along the Kankakee River. Horse Thief Cave is the largest, and these caves are formed by groundwater in one of 2 conditions. So the first condition is normal acidic rain enhanced by acids and overlying rock dissolve the dolomite bedrock. So one cool thing that I love about limestone is that if you take hydrochloric acid, also known as muriatic acid, and you pour it onto limestone, the rock will start fizzing and dissolving. So rainwater always has an impurity of hydrochloric acid in it. So when the hydrochloric acid falls through the groundwater and goes through the bedrock, it starts dissolving the limestone. And once it starts percolating underneath the limestone, it eats away at the limestone and creates these cavities. And these cavities need a way out, so they open holes and creating caves. The other way is groundwater circulates under overlying shale rock, which cannot break through, and it forms a cavity where water was circulating, which is how Horse Thief Cave was formed. Small stack. I'm not sure if you can really see it, but that little bulge right there, that's the small stack. It's formed from erosional patterns of water flow. So the waterfall in Rock Creek Gorge was here, actually, at one point. And water flows through zones of weakness. So it started flowing on the north end at first, but once the zones of weakness became so weak that there was no more, it started to flow on the other way. And my favorite quote is, "Mother Nature has the right to change her mind whenever she feels like it." So if she wants to flow on the north end, she can flow on the south end too if she wants. The clay pit. This was my favorite stop in the Rock Creek Gorge trip. So the clay pit, it forms as a cavity, much like Horse Thief Cave, but instead of just staying a cave, it fills with sediment, and the sediment becomes clay. And the clay will either erode away or harden into a rock over time. A freshwater groundwater spring actually flows out of this clay pit, and there was once a rusted iron pipe, possibly from the Iron Age, found a few feet from the clay pit, and it was most likely used as a spigot for drinking water by the Paleo Indians or the settlers that came here in the early 1800s. I have a video here and a picture of me collecting water from the clay pit. The water actually flows at a decent rate, and it flows down from the clay pit, down the sand bed, I guess you could say, and into the river. So here's, I'm messing with the water, but the water was actually ice cold, really easy to drink and collect. And I believe I show how it goes down into the river. You can see the trail. So the last stop was the small arch. The original arch that was described in the field study guide that I had collapsed. But I found another one. So arches begin as cavities, much like Horse Thief Cave, but instead of just forming a cave, they form a tunnel. And many small cavities, much like the image on the right, can be seen within the walls of Rock Creek Gorge. And a lot of them are inhabited by bugs, spiders, and birds. The waterfall. So when I took the trip, the water levels were at the all-time lowest, and it was wonderful to see it because I could see the levels of limestone sediment and bedrock throughout the eras. The Rock Creek flows at a much smaller pace than the Kankakee River, causing a gorge to be at a higher elevation. Rock Creek formed the waterfall trying to become level with the river. So water always wants an output. Rivers go to oceans, lakes go to rivers, which go to oceans. So the Creek Gorge just wants to get to the river, and it's at a higher elevation, and the Kankakee River's down here. So what it's going to do is downcut. And by downcutting, it creates waterfalls. And over time, these waterfalls start to erode and they move upstream. This waterfall actually migrated 0.7 miles upstream over the past 12,000 years. Here's a few pictures I have from the trip. You can see how low the water level was. You can see the bottom of the Rock Creek. That's not usually something that you can see. The picture on the left, well, your guys is right. So that is underneath the bridge. You can see all of the layers of limestone and dolomite, and I think it's really cool how blocky limestone is because each one of those little layers is at least 1,000 years of sediment. I'll let you guys look at the pictures a little bit longer. So right here you can see there's actually a difference in the rocks. So down here it's darker and covered in algae, but then it gets a little lighter. I can tell that this is limestone because of its color. And then up here it changes from limestone to dolomite, which is calcium magnesium carbonate. So there's at least a little impurity of magnesium at this level. So you can see that the sediment changed one point in time to create a different impurity. And there's another one of the little small arches and holes, cavities, that a bird was inhabiting. Our river is actually vast with a lot of iron. So many of the rocks were stained with iron, and I actually have an iron concentration stone that I found in the river. I'll be able to show you guys today. But the iron stains rocks in the river, and I just thought that was really cool to show. Some more small stacks in an arch. During my trip, on the way back up, I found a cave that wasn't in the trip, and I thought it was a really great thing to share. It was at least 12 feet in depth. It was really cold and really saturated. You could smell the nitrogen in the soil in there. So the soil in there was very fertile, but there's no sunlight, so there was no plants. I just thought that was extremely interesting. You can see how deep the cave goes. Even the cave was stained with iron in the limestone. And just a size comparison. So my favorite part about this picture is the bedrock of Rock Creek Gorge is actually bedrock. It's limestone bedrock. You can see the sand rubble marks, like ripple marks, that have been fossilized into the bedrock. This is a boulder that was carried over by the Kankakee Torrent. The boulders that were carried over by the Kankakee Torrent can be a lot bigger than this, but this one I found at the state park. My favorite part about this picture is you can see the curvature of the Rock Creek Gorge over time, over the millennia. You can see how it widened out and curved at one point here, and up here it was narrower. So it was narrow, and then it was wide, and then it was narrow again. Here you can see it as well, and you can see how it kind of did a little curve on the edge there. So right here, this is a great example of how erosion works with the limestone. You can see it dredging out and becoming sediment. And these are also boulders found right next to the waterfall that was carried over by the Kankakee Torrent. And the beautiful Rock Creek Gorge. The waterfall, you can also see where the levels usually are. It's usually up about here, but you can see the curvature of how the river flows in and out, and narrows and widens over time. And that's my presentation. Anyone have questions?
I do.
Yes.
What month and year were those pictures taken of Rock Creek?
July 2022.
Okay. And then, do you have a sample of dolomite on the table?
Yes, this is a sample of dolomite. Oh, and I also have one, this one, also dolomite, because if you can see here, it's got a sugary kind of texture. What's your question?
You talked about how the gorge narrowed and widened.
Yes.
I imagine that that is in response to water volume.
Yes, exactly.
And what causes the change in the water volume?
Precipitation. So if there's a lot of snow, you're going to get a wider flood seasons, basically. So you can tell the flood seasons how it narrowed and widened the gorge over time.
And about how long does it take for it to move a mark?
Oh, like thousands of years.
Okay, so there were times when there was a lot more water,
Yes.
and a lot more snow.
Any other? Yes?
So, as I understand it, the torrent created kind of islands or lumps in the landscape. Is there a difference in composition between those and moraine? Can you tell the difference between?
The sand sediment. So the outwash actually carried a lot of the sand sediment into the Illinois River, and that's why the Illinois River is a sand river and the Kankakee River is a rock river.
Not anymore.
Not anymore? Any other questions? No? Okay. But you guys can come look at my rocks if you'd like.